Hi, everyone. This is a continuation of Notes 1.9, and we are looking at some word problems in relationship to scientific notation. So, in question number 13, let's take a look at that question for starters. It tells us that the outer wall of a large tourist attraction in Cambodia is about 1.1 times 10 to the power of 3 meters long and 8.1 times 10 to the power of 2 meters wide. So it looks like this. So it's rather large. It's a really large wall. This right here is in the thousands, and this right here is in the hundreds. We want to find the area enclosed by this wall. Now, area is always equal to the length times the width. And since the length is equal to 1.1 times 10 to the power of 3, and the width is equal to 8.1 times 10 to the power of 2, I can go ahead and just multiply these two numbers together. Now, just a reminder, we don't need common exponents for multiplication, so we can just multiply these numbers together. So 1.1 multiplied by 8.1. So 1 times 1 is 1. 1 times 1 is still 1. Then remember when we do our multiplication, we put a 0 here. 8 times 1 is 8. 8 times 1 here is 8. Add these numbers together. So I end up getting 891, but because this is off by one decimal and this is off by one decimal, this is 8.91. So here I know my area is equal to 8.91. Now, if you need to, you can always thin 1.1 times 8.1, and you'll still see that you get this 8.91. So this right here is 8.91 times 10 to the power of, now because we've got 10 to the power of 3 here and 10 to the power of 2 here, that means that we've got 5 tens being multiplied together. So this right here is my area. It's a really, really large number, and that should make sense to you because this number right here is this 1.1 times 10 to the power of 3. That's approximately 1,000, right? And this number right here, this 8.1 times 10 to the power of 2, that's approximately 800. So when I multiply these two numbers together, it's 8 followed by 1, 2, 3, 4, 5 zeros. So we would have an area of 800,000 square meters. Now, quick note, I apologize. This should definitely say meters squared and not kilometers squared because that area of 800,000 kilometers squared is a super, super large area. That's like the area of Ontario. So sorry about that. Okay, in our next question, it says the planet Mercury has an approximate mass of 3.3 times 10 to the power of 23 kilograms. And Neptune has a mass of 1.1 times 10 to the power of 27 kilograms. And we want to know how many times is great as the mass of Mercury is the mass of Neptune. Let's use easier numbers to see if we can figure this out. So instead of 3.3, I'm going to just use 10 kilograms. And I know it doesn't make sense to say that a planet has a mass of 10, but we're just going to use this to kind of help us out a little bit here. And here we'll just say that this is, let's use 20 kilograms here, just to make things a little bit easier for us. How many times is great as the mass of Mercury is the mass of Neptune? So when I think about it, I can say, well, if this is 20 and this is 10, then Neptune has to be twice as great or twice as big as Mercury, right? Because 20 is 2 times bigger than 10. So the way I figure that out is I just divide 20 by 10 and I get 2. So it's 2 times bigger. But that's just for the example with the easier numbers. So now let's do the same idea, but this time let's use these numbers in scientific notation. So instead of 20, I would use 1.1 times 10 to the power of 27. And instead of 10 right here, I would use this 3.3 times 10 to the power of 23. And we would still do our division of those two numbers. So let's see what we get. So just like we always do, I want to divide my coefficients and see what I get when I divide those two numbers. So when I divide 1.1 by 3.3, I end up getting 0.3 repeating. It's a third. 1.1 is a third of 3.3, so 0.3 repeating should make sense. So here I should say this is approximately 0.33 times 10 to the power of, now when I divide, I always subtract my exponents, so this is 10 to the power of 4. But this number is not between 1 and 10, so I need to adjust it so that it is. So I'm going to say 3.3, but I move this over one time, so I'm multiplying this by 10 to the power of negative 1 because I'm technically dividing 3.3 by 10 to get to 0.33. Okay, so because this is a smaller number, we have to multiply it by an exponent with a negative, multiply it by a negative exponent, I should say, because that means we're dividing by 10, okay? And then I'm just going to copy down this 10 to the power 4. Well, when we multiply, we always add our exponents together. So this is times 10 to the power of 3. So this is 3.3 times 10 to the power of 3 right here. So what does that number even mean? Well, 3.3 times 10 to the power of 3 means 3.3 times 3 tens. So 1 10, 2 tens, 3 tens. So that means it's 3,300 approximately. So we can say that the mass of Neptune is about 3,300 times bigger than that of Mercury. And we're done with this question. Okay, so in this next question, it says the area of the Pacific Ocean is this much right here, 1.65 times 10 to the power of 8 square kilometers. Huge, huge, huge number. And the area of the Indian Ocean is this many square kilometers, 7.1 times 10 to the power of 7. It's also a really big number, but this number right here is so much bigger than this number right here. Just by having that extra 10 being multiplied here, it's significantly larger. So when it says find the approximate sum of the areas, it means I just have to add because sum means to add. So I'm just going to add these two numbers together. So I'm going to add 1.65 times 10 to the power of 8 plus, that's this number right here, the area of the Pacific Ocean. I'm going to add the area of the Indian Ocean to that. Now, remember, we have to have the same exponent on the 10. It's like having a common denominator. So right now they don't have the same exponent. One has an 8, one has a 7. So how do I fix this right here? Well, I need to split, either change this 8 to a 7 or change this 7 to an 8. I'm going to change this 8 to a 7. So I'm going to split this up into 10 to the power of 7, but I also have a 10 to the power of 1 here because this still has to be equivalent to this. So I still have 8 tens here. I'm just writing it out in two separate in two separate, these are called monomials here. And then I also have this 1.65 times this. I'm just going to copy the rest of this down. Now I can go ahead and figure out how much this is going to be. So remember, when I multiply 1.65 by 10, it's 16.5. Because you're making it a larger number. And then I'm just going to copy down this 10 to the power of 7. I'm also going to copy down the 7.1 times 10 to the power of 7 as well. Now notice how this ends up becoming a 10 to the power of 7, right? We've got the same exact exponent. So we've got our like terms. So now we can just add our exponents together. So I can add the 16.5 to the 7.1. So let's see what we get. So 5 plus 1 is 6, 6 plus 7 is 13, carry the 1, 1 plus 1 is 2. So I get 23.6 times 10 to the power of 7. But this number is too big. It's not allowed because it's not between 1 and 10. So I'm going to move this decimal place over 1. I get 2.36. Now it's between 1 and 10. But to go from 2.36 to 23.6, I had to have multiplied it by 110. Copy down that extra 10 to the power of 7. I'm just going to erase this over here so I have a little bit more space. So this right here, we know these two will give me 10 to the power of 8. So my answer is 2.36 times 10 to the power of 8 square kilometers. It's really big. But one thing I want you to notice is how this right here, the area of the Pacific Ocean, it went from 1.65 times 10 to the power of 8 And then the total area, including the Indian Ocean, it looks like it didn't get that much bigger, even though this is a huge number, because this number over here is significantly larger. The area of the Pacific Ocean is so much bigger than the area of the Indian Ocean because of that extra times 10 that we have here that we don't have here. Okay, so about how much larger is the Pacific Ocean than the Indian Ocean? Let's talk about this one right here. So to figure out how much larger one number is than another, we have to subtract them. So instead of doing this with addition, I would do this with subtraction. So 1.65 times 10 to the power of 8, and this time minus 7.1 times 10 to the power of 7. So just a reminder, we split this up into 10 to the power of 1 times 10 to the power of 7. This is still 10 to the power of 8. I've just split it up into two separate numbers. Why? So that I have a 10 to the power of 7 to match with. And then just copy down this 1.65 times 10 to the power of 1. And then copy the rest of this down right here. All right, cool. So this right here, when I multiply this, gives me 16.5 times 10 to the power of 7 minus 7.1 times 10 to the power of 7. I'm going through this quickly because I'm literally doing the exact same thing that I did here, except I just have a minus sign instead of a plus sign right here. Okay, so now let me just come up here. This time, instead of adding the 16.5 and the 7.1, I want to subtract them. So 16.5 minus 7.1, 5 minus 1 is 4, and then 6 minus 7 doesn't work, but 16 minus 7 is 9. So I get 9.4 times 10 to the power of 7 square kilometers bigger. So this is a huge, huge, huge number. Having that extra 10 makes a huge difference. So like, let's say, for example, 10 to the power of 3 minus 10 to the power of 2. 10 to the power of 3 is 1,000. 10 to the power of 2 is 100. When you subtract it, you get 900, which is so much closer to this number than it will ever be to this number right here. Let's try a similar example. 10 to the power of 5 minus 10 to the power of 4. This is 100,000 minus 10,000. And when I subtract that, I get 90,000, which is still so much closer to this number than it will ever be to this number. And that's why this right here is such a large, large, large number. Okay, I know this was a lot. If you have questions, let me know. And I will see you in class. Have a good one. Bye.